My name is Sudha Krishna Pramanik. Today we are gonna discuss about internal combustion of engine, which is a fundamental chapter of BME, basic mechanical engineering. So before diving into it, we should have a general knowledge of engine. An engine is a device which transforms one form of energy into another form. Normally, most of the engine converts thermal energy into mechanical work, so that engine are called heat engine. Or heat engine is a device which transforms the chemical energy of fuel into thermal energy and utilized this energy into useful work. Like first chemical energy is converted into heat energy, then it is converted into mechanical energy. And there are different classifications of heat engines, like internal combustion of engine and external combustion of engine. Internal combustion of engines can be defined as those which engines in which engines the combustion of fuel with air takes place inside the engine, like petrol engines, diesel engine, gasoline, Wankel engine, and open cycle gas, and etc. And if we talk about external combustion of engines, these are defined as those engines in which combustion of fuel with air takes place outside the engine, like steam engines, steam turbines, Stirling engines, closed cycle gas turbines, and etc. Now, as we know about internal combustion of engine, there are few advantages and disadvantages of it. Now, its advantages are mechanical simplicity, high power to weight ratio, low initial cost, higher efficiency, compact and lighter. And its disadvantages are high maintenance requirement, large amount of pollutions, difficult to start, complexity and noisy. And there are various applications of internal combustion of engine. This type of internal combustion of engine, in the applications of internal combustion of engine, these engines are widely used in for road vehicles like scooters, bus, car, and trucks, etc. And it is also used in aircrafts and for its maximum power generation and in marine purposes like motorboats, ship, and other engines. It is used in agricultural purposes like tractors, pumps, sets, etc. It is used for earth moving purposes like dumpers, tippers, and mining equipment. Engine nomenclature and material selections. Now, material selection for piston cylinder. In earlier days, cast iron is used for piston, which has a heavy mass. For the heavy mass of combustion engine, it has a higher value of inertia, which causes more power. The less mileage is occurred due to its higher power. So generally, this type of material is used in Chevrolet. For less mileage, instead of cast iron alloy, steels are used in later days. As alloy steel is less heavy, it shows high mileage, which is beneficial and also which makes it more compatible for our use. And the alloys are generally used in pistons than combustion engine. In some vehicles like aircraft, Hyundai, etc., the aluminum alloy is used as it is lightweighted. It gives more mileage than the other alloys, but it is least safe as it breaks easily. Generally, it is known as a duraluminum and like alloy of aluminum. Now, nomenclature of parts of in in এটা কোনটা? In nomenclature parts of internal combustion engine, we can see here it is known as inlet valve and other one like that is known as exhaust valve or combustion chamber, and these sections is known as combustion chamber, and here it is a cold water, it is piston pin, and it is a bore, and here it is crank, it is connecting rod, it is bottom dead center, this is the piston and lower piston ring, this is upper piston ring, this is top dead center, and it is crankshaft or known as path. This figure shows parts of piston for four-wheeler vehicle. Now, cylinder. It is a cylindrical vessel or shape in which piston reciprocates. The cylinder is supported by a cylinder block. Cylinder block, it is more supporting structure for the various component. Piston is the cylindrical component filled into the cylinder dead center. Here no any root is present. It is mainly two types: top dead center, extremely point of piston at the top of a cylinder of a vertical engine is called top dead center. In case of horizontal engine is known as inner dead center or IDC. Bottom dead center. The extreme position of piston at the bottom of cylinder of the vertical engine is called bottom dead center. In case of horizontal engine, it is known as water dead center or ODC. Cylindrical head. It is fitted on top of a cylinder. It covers the cylinder and includes the combustion chamber, spark plug, and valve. It is made up of cast iron and aluminium. Combustion chamber. The space enclosed in the upper part of the cylinder head and top of piston is called combustion chamber. Bore. The nominal inside diameter of the engine cylinder is called bore. Piston ring. Piston rings are fitted into the grooves of the piston to maintain good steel between the piston and cylinder walls. There are two piston rings is two types: upper piston ring, lower piston ring. These are made up of brittle material, steel plus silicon plus graphite, which is smooth. Piston or Gaussian pin. The piston pin is the pin that connects the small end of a connecting rod to the piston. It is more tensile rod load and more comprehensive load. It is made up of forging or cold forging, which has the higher strength, which makes the piston pin non-breakable. Connecting rod. The connecting rod inner connects the piston to crankshaft. Upper rod of connecting rod is fitted to the piston and the lower end to the crankshaft. It has high tensile load and high compressive load. It is made up of medium carbon and alloy steel. Crank. The crank is a lever that is connecting to the end of connecting rod by a pin joint with its other connected rigidly to a shaft is called crankshaft. It converts the reciprocating motion of piston into useful rotatory motion of output shaft. Crankshaft. It is mainly making by high speed steel HSS or forced steel. Failure will occur at a whirling speed. Inlet valve. Inlet valve allowed the fresh air plus fuel mixed into the cylinder. It is made up of nickel chromium steel. Exit valve. Exit valve provide passage for bond gases to escape from the cylinder. It is made up of silichromate steel. Intervalve. There and here it's a picture. Now here we can see this is the exhaust valve, this is output, this is a cylinder, and it is piston ring, it is a piston, and this is the connecting bond. And here this structure is known as crank. It is it is crankshaft, and this is cam, and this one is known as inlet, and it is inlet valve. Flywheel. The flywheel is a heavy wheel that is connected to the extreme end of a crankshaft. The size of a flywheel depends upon number of cylinder and the construction of engine. The flywheel stored the excess energy during the power stroke of the engine and supply the energy for the movement of piston during remaining stroke. It is made up of cast iron. Cam are a integral part of a camshaft. Cams are designed in such a way to open valve at correct timing and keep them open for necessary duration. Camshaft is a shaft on which cams are mounted. It is used to operate the inlet valve and the exhaust valve through follower. The forced steel material used to make it. Classification of IC engine. There are different classifications of IC engine. We in total we have six classifications of criteria, and the number one is number of stroke per cycle, in which we have two types as four-stroke engine and a two-stroke engine. And if we move to another criteria as different types of fuel used, here we have three types of engine like petrol engine, diesel engine, and gas engine. And in other criteria, it depends on method of ignition, in which we have spark ignition engine, and the second one is compression ignition engine. And in other criteria, we have nature of thermodynamics. In this we have three types of engine like OHO cycle, diesel cycle, and dual cycle. Another type of criteria are a number of cylinder, single cylinder engine and multi-cylinder engine. And in last we have cooling system. In this criteria we have two types of engine like air cooled engine and water cooled engine. So now we have four-stroke petrol engine. Petrol engine is also known as spark ignition SI engine, invented by Nicholas A. Otto in 1876. That is why petrol engine is known as auto engine. A four-stroke engine gives a power stroke in every set of four stroke of the piston or two evolution of crankshaft. The petrol engine operates on theoretical Otto cycle. It is also called as constant volume combustion cycle as the combustion takes place at constant value with increase its pressure. The cycle of operation of a four-stroke petrol engine consists of the following strike like step 1 solution suction or intake of stroke, step 2 compression of stroke, and in next expansion or power stroke, and at last exhaust of stroke. Suction stroke. In this stroke, the piston moves from TDC to BDC, creating a vacuum inside the cylinder. During this stroke, the inlet valve keep open and the exhaust valve remains closed. Through the inlet valve, the mixture of air and petrol from the carburetor gets inside to the cylinder, the mixture getting inside of to which the piston reaches the BDC. Compression stroke. During this stroke, both the inlet and exhaust valves are closed. The air-petrol mixture is compressed as the piston moves upwards from BDC to TDC. In compression stroke, pressure and temperature of the air and fuel mixture increased just before the piston reached the TDC. The air-petrol mixture ignited by spark plug. Suddenly, burning of the air-fuel mixture takes place almost instantaneously. It increases the pressure and the temperature inside the cylinder. Volume remains constant during the combustion. Those two-stroke, i.e. suction and compression stroke, completes one revolution of crankshaft. Principle of a spark plug. Spark plug platinum is the best material for spark plug, but instead of platinum, nickel is used generally. We are having a positive terminal and a negative terminal such that for producing a spark very high potential difference are required. For melting purpose electric current should be high. For high spark production the potential difference is very high. Then we have expansion stroke or power stroke, are also known as working stroke. During this stroke, both the inlet and the exhaust valves are remain closed. The high pressure of the products of the combustion due to the expansion of charge pushes tail piston from TDC to BDC. It is called as working stroke as work is done by the expansion of hot gases. And now here we have exhaust stroke. The upward movement of the piston from BDC to TDC pushes out the gas from engine cylinder through the exhaust valve in the atmosphere. These two stroke, I mean expansion and exhaust stroke, completes one revolution of the crankshaft. And now we have completed two-stroke petrol engine. Now we are moving on to four-stroke diesel engine. Diesel engine is also known as compression ignition (CI) engine. It is invented by Rudolf Diesel. The four-stroke diesel engine is similar to four-stroke petrol engine, expect that it operates at higher compression rotation from 14 to 22. In the diesel engine, only air is sucked from atmosphere instead of air-fuel mixture during the suction stroke. In diesel engines, the spark plug is not required for igniting the air-fuel mixture because the fuel is injected and forms an explosive mixture which ignites spontaneously under pressure. Diesel engine works on the principle of diesel cycle. The cycle of operation of a four-stroke diesel engine consists of the following stroke. A first is suction or intake stroke, later on compression stroke, and next is expansion or power stroke, and at last we have exhaust stroke. In suction or intake stroke, during the suction stroke, the inlet valve opens and the exhaust valve are closed. The piston moves from TDC to BDC. The piston movement reduces the pressure inside the cylinder, below which pressure inside is less than the atmospheric pressure, and due to the pressure difference, the fresh air is sucked into the cylinder through the inlet valve. Now we have compression stroke. Here we can see a brief figure how it works. Now, during this stroke, both inlet and exhaust valve are closed. The air in the cylinder is compressed as piston moves upward from BDC to TDC. As a result of this compression, pressure and temperature of the air is increased. Just before the piston reaches the TDC, the diesel engine is injected into the cylinder in the form of a fine spray. The fuel gets vaporized and self-ignited due to the heat of compressed air. The fuel burns instantaneously at constant pressure, and then now we have expansion stroke or power stroke. During this stroke, both inlet and exhaust valves are closed. The combinations of a fresh fuel injected into the cylinder is due to the high pressure and temperature developed during the compression stroke. The high pressure of combustion produces due to the expansion of charge pushes piston from TDC to BDC. It is also called as working stroke as work is done by the expansion of hot gases. Now at last we have exhaust stroke. During this stroke, inlet valve is closed and exhaust valve is open. The position moves BDC to TDC. The burnt waste gases are sent out through exhaust valve and the cycle is repeated. And now we have some important terms like fuel used in petrol engine is petrol and in diesel engine it's diesel. Operating cycle, in petrol engine it is Otto cycle and in diesel engine it is diesel cycle. And charge, it is air plus fuel mixture, and in diesel it's air and fuel is injected. And in petrol engine, fuel is added through carbureted, and in diesel engine it is injected. And ignition system in fuel is spark ignition, and in diesel engine it is compression ignition. In petrol engine, starting of cycle is easy, and in other hand, diesel engine is more difficult to start. Weight of engine is lighter in case of petrol engine and it's a little heavier in case of diesel engine. Output of power is less in petrol as compared to diesel engines. Initial costs of petrol engines are less and diesel engines may cost more. Fuel costs of petrol are more as compared to diesel. Maintenance costs of petrol engines are less and the diesel are more. Vibration produced by diesel engines are less as compared to diesel engines. Noise is produced by diesel engines are more from petrol engine. And at last, space. Petrol engines takes less space while diesel engines requires more space. Engine life is less than 60,000 kilometer and in diesel engine it is 150,000 kilometer. Uses of a petrol engine are in automobile and aeroplane and uses of diesel engine are buses, tractors and truck. Here we have two-stroke engine. Two-stroke engines perform only two-stroke to complete one cycle. Suction stroke, compression stroke, power stroke and exhaust strokes are completed in two-stroke of piston. It means one revolution of crankshaft. In a four-stroke cycle, the power is obtained only one stroke in two revolutions of the crankshaft, but in two-stroke cycle, the power is obtained only one stroke but in one revolution of crankshaft. In two-stroke engines, valve is not used. Here parts are used instead of valves. Two-stroke cycle engines will theoretically give twice the power obtained from four-stroke cycle engine of similar size. In two-stroke engine, its strokes are divided into two strokes or upward strokes as suction stroke plus compression stroke, and the other one is downward stroke, expansion stroke plus exhaust stroke. Here is a brief figure of how suction stroke works. During the upward movement of the piston from BDC to TDC, both the transfer and a exhaust port are covered by piston. The petrol or mixture which is already transferred into the engine cylinder is compressed by the moving piston. The compression process is continued until the piston reaches TDC. At the same time, the inlet part is covered by moving piston and the fresh air petrol mixture enters the cranks through the inlet port. After the piston almost reaches the TDC, the compressed petrol air mixture is ignited by means of an electric spark produced by a spark plug and a combustion starts. The admission of fresh charge into the crankcase continues till the piston reaches the TDC. In downward stroke, the ignited gases expands and forces forces the piston to move down. Thus, useful work is obtained. When the piston moves down, the petrol air mixture is partially compressed in the crankles, thus comparison is known as crankcase compression. Almost at the end of expansion, the exhaust port is uncovered and the combustion product escapes to the atmosphere. Immediately, the transfer port is also uncovered and the partially compressed air fuel mixture from the crankcase enters the cylinder through transport. Two-stroke diesel engine. Flash temperature. The lowest temperature at which a flammable material gives sufficient vapor to ignite in air. Petrol has less flash temperature than diesel combustion with air. As petrol has less flash temperature, so it remains spark plug for combustion, but in case of diesel it has high flash temperature, so it does not require any spark plug for combustion. So in case of diesel engine, the fuel injector is only required. Upward stroke. Here we have a brief figure how a suction stroke works. During the upward movement of the piston from BDC to TDC, both the transfer and exhaust port are covered by the piston. The air which is already transferred into the engine cylinder is compressed by the moving piston. This increases the pressure and the temperature of the air. The compression process is continued until the piston reaches TDC. At the same time, the inlet port is uncovered by the moving piston and fresh air enters the crankcase through the inlet port. After the piston almost reaches the TDC, the fuel diesel is injected through the fuel injector in the cylinder. The combination of a fresh fuel injected into the cylinder cycle takes place due to high temperature already developed in the cylinder during compression of the air. The admission of fresh air into the crankcase continues till the piston reaches TDC. Now, in downward stroke, the bond gas expands the forces the piston to move downward. Thus, useful work is obtained when the piston moves down. The air is particularly compressed in the crankcase. This compression is known as a crankcase compression. Nearly at the end of expansion, the exhaust port is uncovered and the combustion products escape to the atmosphere. Immediately, the transfer port is also uncovered and the partially compressed air from the crankcase enters the cylinder through the transfer port. Now we have a important table which includes some significant terms which we need to remember or understand for the further or deep knowledge about this topic. Number of stroke in four-stroke engine are 4, in two-stroke engine is 2. The number of revolutions in four-stroke engine is 2 and in two-stroke engine is 1. Number of cycles are n is equal to n by 2 in four-stroke engine and n is equal to capital N in two-stroke engine. Power delivered in four-stroke is in every alternate revolution of crankshaft, and in two-stroke it is in every revolution of crankshaft. Fuel consumption of four-stroke engine is less and two-stroke engine is more. Mechanical efficiency of four-stroke engine is low and two-stroke engine is high. Thermal efficiency of four-stroke engine is high and a two-stroke engine is low. Noise produced by four-stroke engine is less as compared to two-stroke engine. Fuel added in four-stroke charge is directly added during the suction stroke, and in two-stroke engine charge is admitted into the crankcase and then transferred to the cycle. Torque produced in four-stroke engine are more as compared to two-stroke engine. Direction of rotation is in one direction in four-stroke engine and in crankshaft rotate in either direction. Initial cost of four-stroke engine is high while two-stroke engine is low. Valve/port is opened by cam in four-stroke engine while port is covered or uncovered by piston. Fuel wheel in four-stroke engine are heavy and fly wheel used, and in two-stroke engines flywheel it is lighter and small flywheel used. Starting of engine of four-stroke engine is little difficult as compared to two-stroke engine. Water and tears in four-stroke engine are less, and in two-stroke engine it has more problems. Engine size of four-stroke engines are large as compared to compact two-stroke engines. Uses of four-stroke engines are like buses, trucks, tractors, cars, and bikes, etc., while two-stroke engines are used in scooters, motorcycles, and etc. So now, air standard cycles. Basic fundamentals of it are like stroke length, the length between top dead center to bottom dead center is called stroke length. It is denoted by letter capital L. Cylinder length. The length between cylinder head to bottom head dead center is called cylinder length. It is denoted by capital L. Swept volume. The volume of TDC to tube BDC is called swept volume. It is denoted by Vs, which is equal to V d square by 4 whole into L. Clearance volume. The volume from the cylinder head to TDC is called clearance volume. It is denoted by Vc. It is expressed in cubic capacity. Vc is equal to pi d square whole by 4 whole into L dash minus L. Total volume, it is the sum of swept volume and clearance volume. It is denoted by Vt. Vs plus Vc is equal to pi d square by 4 whole into L plus pi d square by 4 whole into L dash minus L is equal to pi d square by 4 whole into L plus L dash minus L whole. Vt is equal to pi d square by 4 whole into L dash. Clearance rotation. It is defined as the ratio of volume is not covered to the volume is covered in the cylinder. It is denoted by C. C is equal to volume not covered by volume covered is equal to Vc by Vs. Compression ratio. It is the ratio of larger parameter to the smaller parameter during a process. It is denoted by R. In terms of volume, R is equal to V large by V smaller. In terms of pressure, Rp is equal to P larger by P smaller. In terms of temperature, R T is equal to T large by T small. Compression ratio in P or V diagram, PV diagram. Here it is a brief graph about PV. Assumption of air standard cycle. The working medium is assumed to be an ideal gas and follow the relational PV is equal to nRT. The mass of the working fluid remain constant. The specific heat of working fluid remains constant. All the process are reversible process. Some heat is assumed to be rejected to a constant low temperature sink during the cycle. There is no loss or gain of heat energy. The operation of the engine are frictionless. The working medium does not undergo any chemical changing throughout the cycle. Otto cycle or constant volume cycle process are 1 to 2. Reversible adiabatic compression process 2 to 3. Constant volume heat addition process 3 to 4. Reversible adiabatic expansion process and 4 to 1 constant volume heat rejection process. Here Q is equal to mc dt, Qs is equal to mc r T3 minus T2 and Qr is equal to mcr T4 minus T1.